All righty, friends. Okay.
Bye.
Kinley, you know what Riddance means?
Okay. I'm already recording. Let's go. Focus. Say goodbye. All right. Oh, I don't want to start here. I want to start here. Find your page that says mutually exclusive events. Okay. So we've got two different types of events. We've got mutually exclusive and mutually inclusive. So your formal definition for an exclusive event are two events that cannot occur at the same time. Okay, I hate that definition. So underneath of it, I want you to put does not share anything in common. Okay, so an exclusive event doesn't share anything in common. So, in other words, an even number is not an odd number. They don't share anything in common. Okay, a black card is not a red card. They don't share anything in common. So, those would be exclusive events. Okay. So, in order to solve something that is exclusive, you need to find the probability of both events, and you need to add them together. So, this says, what is the probability of randomly picking a number that is 1 to 10 that is even, or randomly picking a number from 1 to 10 that is odd? So, we call this an exclusive event. Okay, because I'm talking even and I'm talking odd. Well, an even number is not an odd number, so they share nothing in common. Go ahead and sharpen your pencil. I can pause for a minute. Sharpen your pencil. You're fine.
Thank you.
You're welcome. Perhaps. Okay, so if you look at the numbers between 1 and 10, how many of them are even? 5 of them. Okay, so your probability of picking an even number is 5 out of 10. You're 2, you're 4, you're 6, you're 8, you're 10. And yes, that is 1/2. Probability of an odd. 1/2 again, 5 out of 10. To get your overall probability, we add them together. So what's 1/2 plus 1/2? 1. No. This one equals 1 because every number fits into that category. Your numbers are either odd or even. So that's every number available. Okay. The next one's not going to come out to be 1. Okay. So you roll 2 dice. What is the probability of getting 2 on the first die and an odd number on the second? So the first thing I want to get is a 2. The second thing I want to get is an odd number. They're exclusive because 2 is even. So they don't share anything in common. Okay. So what's the probability of getting a 2? 1 out of 6. You've got 1 2 on a die, and there's 6 total sides. What's the probability of getting an odd number? 3 out of 6. We're going to leave it as 3 out of 6 for right now. That way you can add them together. Okay. So I do realize that reduces down to 1/2, but let's leave it right now. So 1/6 plus 3/6 equals 4/6, which reduces to 2 out of 3. Perhaps. Okay. Hang on to that. We're going to do all the mutually inclusive, exclusive, and practice, and then we'll glue all three of them in at once. So we're not wasting so much time. Okay. Yeah. What, Teron?
So you gonna do the examples manual?
Yes.
Thank you.
Okay. If events. Guys, just because I transition does not mean we have a conversation. Stop. Mutually inclusive means that we have something that overlaps. So your two events share something in common. So if you want to put share something in common here, okay. Okay, they share something in common. So this is like you're pulling a black card or a 10. Okay. So I've got two 10s that are also black. So when I count them as a black card and then I count them again as a 10, I've counted them twice. So we need to go through and we need to subtract what they share in common.
Wait, you just lost.
Right.
Hold on. Let's actually do an example. Hold your panties. All right. One card is selected from a deck of playing cards. I want a club or a 10. Well, if you look at my clubs are ace, 1, 2. I've got an ace of clubs, a 2 of clubs, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, and a king. So I have 13 out of 42 that are, 52. Sorry, thank you. 13 out of 52 that are a club. Okay, those are all of my clubs. Then I need to pick a 10. I've got the 10 of hearts, the 10 of diamonds, the 10 of spades, and the 10 of clubs. So I've got 4 10s. So the probability of a 10 is 4 out of 52. Okay, so if these were exclusive, sorry, these are inclusive. If these were exclusive, I would just add them together. But when I added them, remember, these are all clubs. I counted the 10 of clubs here, and I counted it again here. So I have counted it twice. So I need to get rid of the fact that I counted it twice. So you start by adding them. So 13 out of 52 plus 4 out of 52. And then I subtract. How many do I subtract? I only want to get rid of one of them. They share one thing in common, so I subtract 1 out of 52. So 13 plus 4 gives me 17 minus 1, 16 out of 52, which is 4 out of 13. So I double counted it.
Wait, so why did you do 1 minus?
Right.
Why did you minus 1?
There's only one club of 10. That you.
There's only one 10 of clubs in a deck. When I counted all the clubs, I counted the 10 of clubs here. Then when I counted all the 10s, I recounted that 10 of clubs. So I have to get rid of my recount. Okay, hold on. We're going to do some more examples. Okay, we're going to do some more examples, I promise.
Let's say 4 to 13.
Yes, 4 out of 13 is what that reduces down to. All right. Let's do these. Okay. Find the page that says the probability of mutually exclusive and inclusive events. Okay. There are 3 literature books, 4 algebra books, 2 biology books on a shelf. If a book is randomly selected, what is the probability of selecting a literature book or an algebra book? So I want literature or algebra. Is a literature book an algebra book? Are they the same? No. So this is exclusive, which means you just find the probabilities and add them together. So what is the probability that on my shelf I'm going to pick out a literature book?
3 out of 9.
3 out of 9. I've got a total of 9. I've got 3, 4, and 2. So that means I've got 9 total. So it's 3 out of 9 plus algebra book, 4 out of 9. Added together, 7 out of 9. Okay, number 2, a die is rolled. I want to roll a 5 or a number that's greater than 3.
Inclusive.
This one is inclusive, okay? So I want a 5, and what are my numbers that are greater than 3?
4,
4, 5, and 6. So they share something in common, which makes this inclusive. So when I do this, we start with, this is inclusive. So we start with, whoops, my bad, wrong problem. Inclusive. So to roll a 5 is 1 out of 6. To roll something that's greater than that is 3 out of 6. And how many do they share in common? 1. So we subtract 1 out of 6, which is 3 out of 6, which is 1/2. Did that make a little more sense?
Yes.
Okay. Okay. In the math club, 7 of 20 girls are seniors. 4 of the 14 boys are seniors. What is the probability of randomly selecting a boy or a senior to represent the math club at a statewide math contest?
Inclusive.
Inclusive.
The total is 34.
Okay, you said the total's 34. So the first thing I want to pick is a boy. 14 out of 34. 14 are boys. Plus, I now want to pick a senior.
That's 34 out of 34.
No. 11, you're right. 7
7
are seniors. 4 are seniors, which gives me 11. Then what do I have to subtract? How many seniors are also boys? 4 out of 34. So that's 25 minus 4, 21 out of 34. And I do not believe that reduces. I lost you. Where did I lose you?
So 7 over 20 are seniors.
So we've got 20 total girls. I've got 14 total boys. So you're good with the 34.
Can you show myself?
7 of these are seniors. 4 of these are seniors. So I have 7 seniors and 4 seniors, which means I have 11 seniors. This is my overlap because I counted boys and I counted seniors, and 4 of them are both. So you have to subtract your overlap. Hold on.
Thank you.
Perhaps.
Alright, so let's do, I'm gonna do the boys in blue. So we've got boy, 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 5, 6, 7. I don't know how else to do this without visually. Boy,
So you're gonna
boy,
write 34
boy,
boys?
boy. There's all your boys. Okay. Here's all your girls. 1, 2, 3, 4, 5. 1, 2. Girl, 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 girl. My arm hurts. It's all Tay's fault. Girl, girl, girl. Okay. So, the first thing I need to count is all of the boys. So, that is all of this. That's where 14 out of 34 came from. Okay? Now I need to count my seniors. Well, I've got 7 of the girls. So this many girls are seniors. And 4 of the boys. So this many boys are seniors. So that gives me my total of 11. But if you look at my boys, I counted these already when I counted my boys. Then I counted them again when I counted them as a senior. So I need to get rid of the fact that I counted those 4 twice.
So if you would have asked what's the probability difference of girl, you would put -7.
7, yes, because I have 7 girls that are seniors. Yes. Okay. That help? Tell me the other ones that were lost. Beautiful.
Miss Smith, you didn't have to say that. Nobody else was lost but me.
Listen, just because people don't ask questions does not mean they're not sitting there going, which is why I love this class, because I've got people in here that aren't afraid to be like, Ms. Smith, help. Because just because they don't voice their opinion, you got quiet ones that sit here and like, I don't know what you're talking about. But I'm not about to ask my questions.
Michelle.
Alfredo.
No, they probably get it. Roll the
All right. A card is drawn from a standard deck of cards. What's the probability of drawing an ace or a face card?
Exclusive.
Exclusive. None of my aces are also face cards. Remember, a face card has to have a face on it. So this is exclusive. So what's the probability of an ace? 4 out of 52. What's the probability of a face card? 12 out of 52. Nope, because they don't share anything in common. 16 out of 52. Only if it overlaps.
So, like, only if it's the same.
Yes, ma'am.
Can you send Jonathan Williams to the office just for a moment, please?
Sure.
Thank you.
It's 231.
You said it was what?
It's 231.
Reduced.
Reduced.
I'm talking about my,
Over 13.
what, 4 over 13?
Wait, so Miss Smith,
Yes.
so you
Okay,
only
just
subtract.
because somebody got called out of this classroom does not mean we have individual conversation about what's not happening in here. I'm tired of hearing it. Stop making me yell. It's getting really annoying. Shut up. Talk about your stuff outside of class. What was your question now?
You only subtract if something is alike.
If they share something in common.
So you will only subtract if it's inclusive.
Yes. You only subtract if it's inclusive. Okay. One tile with each letter of the alphabet is placed into a bag. So how many total letters do I have in there? Thank you. Okay. Because I can't say how many seniors were like 32.
25. Yeah,
Like,
I literally thought it was 32. But
okay. What is the probability of selecting a vowel or a letter from the word equation?
I have a question.
Yes.
Are we including Y?
As a vowel? No, they will tell you if you want to include one.
Inclusive.
This is inclusive. Okay, this is inclusive because the word equation has vowels in it. Okay, all of them, right?
No.
So,
What? A-E-I-O-U. Oh, it is fine.
okay, so there are 5 vowels in the alphabet. So selecting a vowel is 5 out of 26. What's the probability that I'm going to pick a letter from the word equation?
5 out of 26. 8 out of 26.
Thank you.
There's 8 letters.
E-Q-U-A-T-I-O-N.
Letters. Oh, like any letter, not specifically a vowel.
So when we subtract.
I'm lost.
Okay,
Yeah.
so how many vowels are in the word equation?
5.
5. So I have to subtract off 5 out of 26.
8 out of 26.
So your answers here is 8 out of 26,
Or 4 of 13.
4 out of 13.
That just blew my whole mind. How'd you get?
Talk to me, Jackie.
Whatever. I'm good.
Good? Anybody else? You've got to stop me if you want me to explain farther.
Minus 526.
Huh?
How'd you get minus 526?
Look at the word equation. How many vowels are in that word? 5. So because I counted them as a vowel and then I counted them again in the word equation, I have to take away the fact that I counted them twice. They share 5 things in common, all 5 of the vowels.
I ran into Pittman. He said he would just tell him you have it and that we'll get it to him.
Okay.
We're still not certain if he's coming tomorrow or not.
Okay.
All these teachers running around for this, you see.
Singers are very important.
I did.
Perhaps.
I did.
Okay. Each of the numbers from 1 to 30 is written on a card and placed in a bag. If one card is drawn at random, what's the probability that the number is a multiple of 2 or a multiple of 3? This is inclusive. All right. So before we do this, you're probably going to have to write these down. Okay. So my first event, I want multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30.
Yay!
All right, so my first fraction is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 30. Plus, now I need my multiples of 3. 3, 6, 9.
12, 15, 18, 21, 22, 27, 30.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 30.
Does that only work for this, or could you like next time like? And then it's minus 4.
Wait, what?
Like if they want multiples of 2, like.
Yeah.
Does that always work?
All right, hold on. What's my multiples of 4? So that's 4, 8,
There's 5.
12, 16, 20, 24, 28.
Smelling like.
7. I know. I like that.
I know it's 5.
Okay, so
4.
now I need to figure out what do these share in common? Will they share a 6,
They share 12,
a 12,
18,
18,
24,
It's 5.
24,
and a 30.
and a 30?
Which is 5.
So that's 1, 2, 3, 4, 5. So I have to subtract 5 out of 30.
I think you need to.
So 20 over 30.
So yes, 20 out of 30 or 2 over 3.
Thank you. Did you say perhaps?
Perhaps. Kaisha has a stack of 8 baseball cards, 5 basketball cards, 6 soccer cards. If she selects a card at random, what is the probability that it is a baseball or a soccer card?
Exclusive.
Exclusive. Baseball. 8 out of 19. Plus soccer. 6 out of 19. Which gives me 14 over 19. 19 is prime, so we done.
I like exclusive way better than inclusive.
I
It's
do too,
easier, though.
perhaps.
It's easier, right?
I like the little pockets.
I like my little pockets.
It's so cute.
Okay, there are 8 girls and 8 boys on the female Senate. 3 of the students are seniors.
On the
Student.
student senate. You said the female senate.
Whatever. Let it
Yes.
You're sexism.
go. I'm sick.
Sexist.
Sexism.
Okay, y'all.
What is the probability that a person selected from the student council is not a
Oh, you
senior?
have to drop it.
Exclusive.
16.
Yeah.
16 minus 3.
13.
13 out of 16.
I don't know, man. Everybody-
Yep.
So we don't have to do that.
Nope.
No, they're really, this one's really not even an exclusive inclusive. I don't know why they did that. It was just randomly in there. Probably.
That's how they get you. That's how they gonna get you.
So if you have a total,
You have to explain.
if you have a total of 16, you've got 8 girls and 8 boys, so that's a total of 16 kids in a class. 3 of them are not seniors.
Hey, Golly.
Or I'm sorry, 3 of them are seniors. So 3 of the 16 are seniors, which means the 13 remaining ones are not.
And that's good.
And a one's not a senior. So it's literally, there's 13 non-seniors. That's Betsy's senior, or sister.
Yeah.
Yeah.
Does she not look like her? Look at her.
Yeah.
You do.
Look at
You
her.
like Nancy's sister too, though. Like,
That's your stuff on the back. Like,
Okay.
you got a letter, yeah.
Yo.
Look, Harley, you got a letter.
Who?
So you get a letter extracted.
From who?
I wrote you a letter.
Oh, you did?
Yeah.
You just got a letter.
You just got a letter. You just got a letter. I wonder who it's from.
You're welcome.
Oh, I know. Oh, no. Oh, just wait. Hold on. Okay. A card is drawn from a standard deck of cards. What's the probability of drawing a 6 or a king? Exclusive. Exclusive. I don't have any 6s that are also kings. So what's the probability I'll get a 6? 4 out of 52. What's the probability I'm going to get a king?
4 out of 52.
Which means my total is 8 out of 52. 26, which is 2 out of 13.
Yep.
Okay.
Gotta love it.
A die is rolled. What's the probability of rolling a 2 or a 6? Exclusive. Sorry, hold on.
So that will be ones that are neither exclusive or inclusive.
Yes, it's possible. Okay. So you said this is exclusive. What's the probability of getting a 2 out of a 1 out of 6? What's the probability of a 6? 2 out of 6 or 1/3.
You just get easy.
The more you practice, which is why you usually have homework in math class.
It's really.
Perhaps it's not.
Perhaps.
I thought
Perhaps it actually benefits people.
It's not good for your health.
I thought it was punishment. Right.
It really isn't. I just improvement.
Okay. Sylvia has a stack of playing cards that consist of 10 hearts, 8 spades, 7 clubs. This just means that she played 52 pickup and lost some stuff. Okay. If she selects a card at random from this stack, so we're not 52 total cards anymore. She's lost some. Okay. What is the probability that it will be a heart or a club?
$17.
Okay, first up, inclusive or exclusive? Exclusive. I don't have any cards that are hearts that are also clubs. Okay, so hearts. 10 out of 25. Plus, I need a club. 7 out of 25. 17 out of 25. Whoop, there it is. Okay, perhaps this is our last one. A card is drawn from a standard deck of cards. What is the probability of drawing a queen or a spade? Inclusive. So, queen. 4 out of 52. Spades. 13 out of 52. Minus 1 out of 52.
You were skipping to the end.
16 out of 52 reduces to what? Do you understand why we subtracted 1 out of 52?
Yes.
Okay.
You didn't understand.
Okay. So, those 3 pages, please stop talking. Those 3 pages blew in on 163, 164, and 165.
Nice.
Then we're going to jump to this big page on compound events. You're going to fold it in half. Bye, Lolly.
I love every single one of you.
We love you too. Well, not Emma. Emma doesn't love you.
Emma can suck your toe.
Really?
Ew, I don't suck toes.
That's
No, we
gross.
are recording. We are still on recording.
And you're all real gross. Right, talking about some toes. Y'all are disturbing. Fungus.
I don't think I have food fungus. I think this kind of gross. Perhaps it's very gross. See you all tomorrow.
Did they call you?
No, I don't want to be good.
Okay, as you're gluing, please listen. Okay, this requires mouths to be shut. Okay, so mutually exclusive and inclusive events. One thing was happening. We were doing this or we were doing that. Okay, so we were only doing one thing. We were picking a queen or we were picking a spade. We were picking a 2 or we were picking a 6. Compound events are where more than one thing happens. Okay, so these are the types of problems where you spin a spinner and then you spin it again, or you roll a die and then you roll it again, or you pick a card and then you pick another card. Okay, you're not just doing one thing, you're doing more than one. So, this says, it is possible to find the probability of more than one event. I'll give you a second to get all organized here. You're fine. Okay.
Don't rush.
So, it's possible to find the probability of more than one event. A compound event consists of more than one. Okay, then give yourself some examples of what a compound event would be. Again, spinning a spinner more than once, rolling a die more than once, picking a card more than once, picking marbles more than once. These are all different types of compound events. Okay, yes. That one was a full page over here. It just needs folded in
Right
right
there.
I only folded or stapled the half pages because there were so many of them. If I laid them across, y'all would have been like, so we tried to make it a little easier, a little
Oh, I
faster.
got two of the same thing.
We'll put one in the back.
Oh,
Each side, go see it through.
Being. When's the last day from Ecuador for you?
I will give you guys till next Friday. I'm only giving my seniors till this Friday because we're done with their stuff. And been done. So I ain't playing.
See, man.
Okay, so once you get this, I want you to open it up. And we're gonna talk about the two types of compound events. Okay, do you remember in middle school talking about independent events and dependent events?
Yeah.
Kind of, sort of, maybe? You recognize the words at least, right?
Sure.
Sure. Okay. We'll go with that. We'll fake it till we make it, right? Okay, so let me give you the formal definition and then maybe you can think of some things that are independent events. So, the independent event is the occurrence of one event does not affect the probability of the occurrence, I know, big words, of the other. While you're writing this, think about what that means. Really? You had to go morbid on me?
Who?
Tavarius, he said, just because one person dies doesn't mean another one will. What's up, Taylor? What? I don't have time right now. Yeah. We still got 2 more lessons to cover. Not today. I'm probably leaving today. Can you bring it back? Yes. Can you bring it back next week? We got senior assembly tomorrow. You don't want to drag it here tomorrow.
Yeah, I know.
Bring it back next week. I love you.
You want to see him trip?
Uh-huh. We'll bowl.
I will bowl.
We are. We're gonna bowl. Don't be jelly. Oh, you are.
Going on a date with my girlfriend.
That's right.
I'm kind of jelly.
Yeah, she kind of jelly. Hey, what in the world does this mean?
It
So
means that
one
it
day
means
doesn't
that you
affect
change.
the probability. The probability of one event doesn't affect the probability.
Really?
Is that what it is?
So, you remember doing problems where it said with or without replacement?
Nope.
No idea what you're talking about.
It would be a
Okay.
fellow.
Guys, I'm gonna tell you this right now. Math 3 teachers do not have time to go over again what I have covered this year. So y'all had better, I don't know, find some way to practice over the summer.
We learned
You
it
think
last
they're
year.
gonna do this crazy stuff next year? Because you all were taught this in middle school.
I had like terrible teachers.
I didn't have
I don't care how
In middle
terrible your
school,
teacher
We had
was.
to sub.
I didn't have.
I don't care. I don't care. Stop making excuses.
We
If
didn't have-
excuses are
we
not
really
gonna
didn't have a
fly.
teacher. We had to sub.
Okay,
The whole year.
listen,
Mr. Brunk.
listen.
And Ms. Williams.
Again, You should have at least been exposed to this at some point in time.
No, we got exposed when it was time to review. Honestly. Mr. Denny's having.
Well, I mean, she just threw it out there. Okay. All right. So, an independent event is where I'm not taking away any of your choices. Okay. So, I like to put the total never changes. Okay. So, what are some examples of independent events? Flipping a coin twice. Okay, think about it. When I flip a coin, how many choices do I have? Heads or tails, so I've got 2. When I flip it again, I still have 2. You're not taking any choices away. So it is independent. Okay, so spinning a spinner twice. Rolling a die twice. Picking a marble and putting it back is independent because you're replacing it. You are putting it back in the bag, which never changes the total. So anything with replacement is an independent event because I'm not changing how many options I have to pick from. Does that make sense?
Sure.
Now, if you would have took it and kept it out.
If you would have took it and kept it out, that would be called a dependent event. Because it depends on what I pick and keep, and that changes the outcome of my second event. Okay? So, to figure out the total probability, you take the probability of A and you multiply it against the probability of B. Okay, so this time instead of adding, we're multiplying. I need to switch up my colors again. I'm tired of green. It's boring. Okay. If we flip to the other side, dependent event. Here's your formal definition. The occurrence, I know you hate big words. The occurrence of one event impacts the probability of the occurrence of the other event. Or in other words, the total goes down. Okay, so your total is going to go down. So if something is dependent, you're looking for these keywords. Keep it or no replacement. Okay, so if I start with 20 marbles in a bag and I pick a marble and I keep it, the next time I go to pick a marble, I only have 19 to pick from. So my first probability would have a total of 20. The second probability would have a total of 19. Okay, so we're going to do some examples. You'll get to see what I'm talking about. Okay, so those are your keywords. The beautiful thing though, huh?
5 seconds to get, yeah.
Okay. The beautiful thing is though, where you put the probability of dependent events, you still multiply. It doesn't change what you do with the two numbers. So down when it says probability of dependent events, you're still taking the probability of A and I'm multiplying it against the probability of B. I know because Tay is copying stuff for Lolly. Because it'll look exactly the same as what you wrote on the other side for a probability of independent. Yeah.
I'm good.
You good?
Yeah.
Okay. So when I actually go to calculate it, this doesn't actually change at all. I no longer.
What'd you put for this?
You can just put any examples you want. So, spinning a spinner twice, flipping a coin twice, rolling a die 3 times. We got this. We got this.
I gotta do mine and him.
Okay. We will glue all these in at the end. Okay. All right. On this page. Okay. We're going to go to this full page. Okay. Listen, right now, we are not going to cut these out. You can cut them out after we are finished. I'd like to get through the notes and then you have time to cut them out. So we need to decide all of these events, where in the heck are they going to go? What are they? Are they independent or are they dependent? Okay, so if I'm flipping a coin, Jackie said that's independent. Why?
Because it's not changing.
It's not going to change. Every time I flip a coin, I still have 2 options. It never goes down. I cannot erase the tail side of a coin before I flip it again. Okay, it doesn't go away. What about selecting a letter tile, then selecting another one without replacement?
Dependent.
That's dependent. What about selecting a random card, then selecting another without replacement? Dependent. Rolling a 6-sided die 3 times in a row. Independent. Again, you're never taking away an option on a die. Choosing one player to be on your team, then selecting another. Dependent. Okay. Think, when you're talking people, it's always dependent. If I pick Jackie to be on my team, Bobo can't have Jackie. I got her. Okay. So she is off the table. She's no longer an option. Spinning a 5-section multicolor spinner 4 times.
Independent.
Independent. You're not taking any way of your options each time you're doing it. Selecting a letter tile, then selecting another with replacement.
Independent.
Independent. You're putting it back. Okay, so once we're done with these examples that we're about to finish, you can cut those out and glue them in the ones that you want. If you don't want to cut them out and glue them, you're welcome to write them in where they belong and then glue that in. Or if you really want to fold them in half and glue it in, I don't care either. Thank you.
Okay, this one?
Hold on, we'll do it all here in a minute. I want to get through all these examples and then we'll glue everything in.
Now it's back to the little book, right?
Yes. Okay, so we're going to do independent, then we're going to do dependent, then we're going to do practice. Okay. So, independent says you flip a coin twice. What's the probability of flipping a head both times?
2 out of 4.
So, I need the probability of getting a head. 1 out of 2. Then I want to get another head. So what's the probability of that now? 1 out of 2. We now multiply. So my final answer is 1 out of 4. Remember, when you multiply fractions, it's straight across the top. So 1 times 1 is 1. Straight across the bottom, 2 times 2 is 4. Okay, now I'm flipping it 3 times. So I want a head, which is 1 out of 2. Then I want another head.
1 out of 2.
Then I want another head.
1 out of 2.
So my final answer is 1 out of Whoa, multiply.
8.
Thank you.
I wrote 6. Crap.
Okay. Your biggest thing is making sure when you're doing it and doing it and doing it that you multiply, not add. Okay. You're rolling a 6-sided die twice. What's the probability of an even number, then an odd number? So I want even, then I want odd. What's my probability of rolling an even?
3 out of 6.
3 out of 6. What's the probability of an odd?
3 out of 6.
Which is 9 out of 36, which is 1 out of 4.
Crap.
Okay. Number 4. I'm now doing a die 3 times. The first time, I want an even. The second time, I want a 6. The third time, I want a 1. Yes.
So we can do like any problems like this,
Mhm.
not just the independent and missing.
So 3 out of 6. 1 out of 6. 1 out of 6. So that's 3 out of 260. 216. 3 out of 216, which I know reduces to 1 out of 72.
Yeah, let's put that. Yes.
1 out of 72. Did you notice though, each time I did the probability, I still had 6 choices straight across the board. I still had 2 choices straight across the board. That's what makes those independent. Okay? So now, let's look at some dependent events.
Okay, are you like using up or is it like?
Listen, we can copy the other ones later. Just get yours done for right now.
Okay.
It's fine. Without replacement. That's what makes this dependent. I'm not putting it back. So I'm picking one of these cards and then I'm keeping it. Okay? So 1 says, I want the probability of a 1. So I want to pick a 1. Then I want to pick a 2. What's the probability that I'm going to pick a 1? 1 out of 6. Okay? I now take away that card. Now I want a 2. 1 out of 5. So 1 over 30. Okay. The probability of a 3. 1 out of 6. I pick that 3. Now I have 1 out of 5. Okay. Number 3. Now I want to pick an even, then an odd. So 3 out of 6. I pick one of my even ones. Now I want to pick an odd. 3 out of
3.
I'm picking 1 even. Don't take out all of your evens. You're only taking one thing out when you pick, not all 3 of your evens. It just doesn't tell me which even I'm picking out. I'm picking any one of the 3. Okay. Why does my top number also go down or not go down?
Because you still have even 3 of them.
Because I still have 3 odds. I'm not picking an odd. So if this said pick an even, then another even. Does that make sense? Hold on. Let's finish this. Hold on. So this is 9 out of 30, which is 3 over 10. All right. So let me go back to this. So we've got 1, 2, 3, 4, 5, 6. Okay, so if we're doing even, then an odd. Okay, so the first thing I want to pick is an even. Well, I've got 1, 2, 3 evens out of 6. Which even do you want to pick?
5. I meant 2.
Wow. Okay, so I'm only picking one thing before I want to pick an odd. So now instead of having 6, I have 5. And I have 1, 2, 3 odds left. So I got 3 out of 5. That's where that came from. Now, if I'm doing an even, then an even. Well, I start with 3 out of 6. But when I pick an even this time, when I go to pick another one, I'm down to 5, but I only have 1, 2 evens left instead of 3, because I've already picked one. So when you're picking the same thing without replacement, not only does the bottom number go down, your top number also goes down. Okay, does that make a little more sense?
Yeah.
Huh? Yeah. We could do even, then odd. So all you would do, even, then I want an odd. So I picked an even, I'm picking another even, now I'm picking an odd. So now I've got 3 out of 4. Because I've got 3 odds left and only 4 choices. You can keep going until everything is taken out of that bag.
So when you're doing that, it'll always go down by 1.
Because you're only ever picking one thing. The thing that people get confused of, and I think that's where Bobo was going when he said out of 3 the first time, because we've got 3 evens. People think that this should drop down by 3, but you're still only picking one of those evens, not all of them. So these are your options, but you only pick one. So it should never go down more than 1. Okay. So keep that in mind. What about this last one? Probability of a 1, then a 6. 1 out of 6 and 1 out of 5. So 1 out of 30.
I'm so ready to go home.
You say your allergies? Yeah, mine too.
Sure, it's allergies.
Oh.
The allergies.
No, Alex.
Okay.
Is that a hiccup?
Let's do this last one. Okay. So this is a mixture of the two. So you can tell me whether it's independent or dependent, then we're going to do it. You roll a 6-sided die twice. This is independent. All the women who are independent.
Hey. Hey.
Okay, so the first thing I want is an even. 3 out of 6. Then I want an odd. Careful, it's independent. 3 out of 6. So 9 out of 36. Or 1/4. Okay. Remember, independent means I don't take any chances or any choices away. Okay. You cannot erase a side of a die. You have 5 cards, each with a different vowel. You select one card, then another without replacement. This is dependent. You're keeping your stuff. So I want an A. Then I want an E. 1 out of 5. And then 1 out of 4. Which is 1 out of 20. Okay, because again, once I pick that A card goes in my back pocket, and you only have E, I, O, U left. So you only have 4 choices to pick from.
I have a question.
Yes.
So your bottom number is gonna be the one that's gonna change unless they ask for the same thing twice?
Yes. Your bottom number is the only one that will change unless they're asked for the same thing twice. Absolutely. In a bag, there are 6 marbles. There's 2 red, 3 green, 1 blue. You select one marble, then another without replacement. Dependent. Okay, I want a red, then a blue. 2 out of 6. And hold on. Yep, 1. Sorry. 1 out of 5 because I only have 1 blue. So 2 out of 30. 1 out of 15. Now, if they would have said red, then red, it would have been 2 out of 6 and then 1 out of 5. Because once I take the red, I keep the red, which means there's only 1 red left and there's only 5 marbles left.
Why wouldn't it be 2? Why wouldn't it be?
Because you're only picking 1 at a time. Even though you have 2 to pick, you're only picking 1 at a time.
So the problem is just the.
It's not how many you're taking, it's how many are there for you to take. Okay. You flip a coin 4 times. Independent. Okay. So this means I want a tail, then I want another tail, then I want a head, then I want a tail. 1 half, 1 half, 1 half, 1 half. 1 out of 60. Okay. Let's glue these all in.
Oh, boy. That was fun.
Oh, fun. I told you we'd get it all done though, didn't I? Okay. So all of these start on page 166. You want compound events here. And the one, if you don't want to cut it and glue it, just fold it in half and stick it here. I don't care. If you want to cut it and glue it, go for it. So 166 and 167. $168 should be your independent events. 169 will be your dependent, which means 170 will be what we just finished. Yes, ma'am. We have a problem. Glue them together. You should be fine.
Right here, because like they're like stuck together.
That's fine. Just glue them together. You'll be fine. We're not going to use the whole book. So you'll be fine. I know. We're going to finish at like 176. We don't have any papers tomorrow. Y'all have IXL tomorrow in Miss Miller's room. Because I'll be bowling.
Can I use somebody's glue? No. All of mine literally. Well, that sounds like